All right, everybody, we are on to acceleration, accelerated motion. We are continuing on from velocity and speed. This is kind of the next step. So let's talk a little bit about what acceleration is. So the technical definition is acceleration is the rate of change of velocity over time. Coffee cup is bouncing and making noise. Hang on, let me fix that. So it's the rate of change of velocity over time. It is represented with an A value, A, and that symbol because it is a vector quantity, which makes sense. It has velocity in it, which is also a vector, so acceleration is a vector. Anytime an object's velocity is changing, it's accelerating. That seems weird. Well, it makes sense if we're going faster, right? Because if you're at a traffic light and you're stopped, and then the light turns green, and you push the gas pedal, you're going to start to go faster and faster. Therefore, your velocity is changing, or you're accelerating. But it also works, or it's also considered acceleration if you are moving at 60 kilometers an hour and the light turns red and you start to slow down to stop because your velocity is also changing. So this works whether you're speeding up or slowing down. Positive acceleration and negative acceleration. Some people use the word deceleration. Not a fan. Don't think it's a real word. This is positive acceleration and negative acceleration. So let's look at this. Oh, wait, the formula. Let's do that. The equation is going to be acceleration is equal to change in velocity over time. Or, if it helps, velocity final minus velocity initial over time. Because change means always final minus initial, always. So we've seen it with change in displacement. Now we see it with change in velocity. So change in displacement was displacement final minus displacement initial, or position final minus position initial. Change in velocity is velocity final minus velocity initial. So maybe I'll write that down. This means acceleration. This means time. And this means change in velocity. Yay, go us. The units for acceleration, this is something that we can also talk about. Well, we know, let's just do a little bit of a unit analysis. If we're doing velocity, that's going to be meters per second. Over time, that's seconds. And so I don't know if you remember when you divide fractions, then you flip and multiply. The units for acceleration come out to be meters per second times second, or more commonly, meters per second squared. That's our units for acceleration. All right, let's dive into some problems. Example 1. A sprinter starts from rest and reaches a speed of, let's zoom in, 12 meters per second in 4.25 seconds. Find their acceleration. For this one, I'm not going to draw a picture. I don't think it's necessary. Sometimes it will be. It's up to you. It always does. I think it always helps, but in this case, we don't really need it. So let's write down what we know. A sprinter starts from rest. This is a word you're going to see lots in physics. Starting from rest, what does that mean? That means you're not moving, right? You're starting and you're not moving. So that means the initial velocity is 0 meters per second. Starting from rest. And the sprinter reaches a speed of 12 meters per second. That will be VF. their final speed. That's how fast the sprinter is going. And they do that in a time of 4.25 seconds. Sorry, I'm just zoned out a little bit. And what are we looking for? We are looking for acceleration. So it's always nice because now you have a list right here of all the things that you know and or are looking for. And now we can just use, we can go to our handy dandy formula sheet and find a formula that works. Obviously, we're going to be using the acceleration formula because I just introduced you to it, but in the future, you might not know that. So it's nice to see, hey, I have velocity final, velocity initial, I have time, and I'm looking for acceleration. So that gives me the formula of acceleration is change in velocity over time, which is v final minus v initial over time. And we have all of those values. So we can say 12 meters per second minus 0 meters per second all over 4.25 seconds. So we can do that in the top. 12 minus 0 is just 12, and then divide by 4.25, and that gives us 2.8 meters per second. And that's our acceleration. And the direction comes from the sign. That's a positive 2.8. That was a positive velocity up here, which means we are accelerating in the positive direction or the same direction as we were running. So you don't have to write the positive. It is assumed that it's there. The only time you have to really specify is if it's going negative, right? We assume that's a positive number, so that's there. Example 2, a car starts from rest and accelerates at 15 meters per second for 3 seconds. What is its top speed? Okay, so top speed, I've written it here, but you won't be told this in the future. Top speed means final velocity. How fast are you going at the end of this problem? So we're looking for v final. What do we know? Well, the car starts from rest. So starting from rest means our v initial is 0 meters per second. It accelerates. You know, acceleration is 15 meters per second squared. And we know it does this for 3 seconds, so we know the time. So again, we are going to use the acceleration formula. And we do want to write that down. So we are going to say acceleration is equal to v final minus v initial over time. And it's going to be really important, or it's just a good habit to be in, to manipulate this formula beforehand. So I'm looking for v final. I'm trying to solve for v final, so I want to isolate it, get it by itself. So there's 2 things happening to this v final. It's being subtracted by v initial, and it's also being divided by time. Because that time is dividing by both of these values up here, we have to deal with that time first. So I'll multiply both sides by time, and I get that cancellation. So now I'm left with, I'm going to flip these around, acceleration multiplied by time is equal to v final minus v initial. Now I can add that v final, I want to get rid of that, or v initial, sorry, so I'll add v initial to both sides, and I have the equation v final is equal to acceleration multiplied by time plus v initial. So now I can just plug things in. V final is going to be acceleration, which is 15 multiplied by time, which is 3, plus v initial, which is 0. So 15 multiplied by 3 gets me 45. It's a velocity, so I should have meters per second. So our v final is 45 meters per second. Hopefully that makes a little bit of sense too, because we're starting at 0. And then for 3 seconds, our speed is increasing 15 meters per second. So after the first second, we're traveling 15 meters. After the second, we're traveling 30 meters per second. And after the third second, we're traveling 45 meters per second. Cool. Example 3. If you want a good strategy here too, if you want to pause these videos and try these problems yourself, if you're feeling confident, That's always a good idea for understanding. It will help you come to class with a really deep understanding, or at least a bit of an understanding because you've tried these problems before you've gotten to class. I also get it if you're just pretty tired, you've been working or something, and you just are taking notes. But if you do have the time and energy, it is good to really engage with this material. It will just make everything a lot easier once you're in class. So it says here, if a snowboarder is traveling at 8 meters per second, how long will it take them to reach 36 meters per second if they can accelerate at a rate of 3.5 meters per second squared? So again, let's make our list. What do we know? A snowboarder is traveling at 8 meters per second. How long will it take them to reach 36 meters per second? So it sounds like to me, didn't realize I had my highlighter on. Sounds like to me that VI, the initial velocity, is 8 meters per second. And they're reaching a speed, so their final velocity is going to be 36 meters per second. How long will it take them to reach that if they can acceleration at 3.5 meters per second squared? How long will it take them to reach that? So how long? Always, how long is solving for time. So time is equal to question mark. We can zoom out a little bit so we can see the question. How long will it take the snowboarder to increase their speed from 8 to 36 if they accelerate at a rate of 3.5 meters per second squared? So again, we are going to use the acceleration formula. It is v final minus v initial over t. And in this case, we are trying to solve for t. We're trying to solve for time. So what we want to do is isolate time. The problem right now is time is on the bottom of a fraction, and that also doesn't work for us because we don't really care what 1 over time is equal to. We want to know what time is equal to. So not only do we have to isolate it, but we have to get it into the top of the equation. So the quick trick here is we're just going to, if t's in the bottom, let's just multiply both sides by t. Watch what happens. The t's cancel out on this side, and now my equation is a multiplied by t is equal to v final minus v initial. Now t is in the top of the equation, so we've achieved that goal, and now we just want to isolate it. So what's happening to t? Well, it's being multiplied by acceleration. So we want to get rid of that acceleration by doing the opposite operation. So if a is being multiplied, then I will divide a from both sides. So we get a cancellation here, a over a, and now we've got time is equal to v final minus v initial over the acceleration. And we've got time by itself. Now we can plug everything in. So v final is 36 meters per second. Subtract v initial is 8 meters per second, all divided by acceleration, which is 3.5 meters per second squared. So what we're left with is 36 minus 8 is 28 over 3.5, and then we can divide that to become 8. And our units, we know time, so if we have seconds everywhere, our time should be seconds. We can do unit analysis if we want. Meters, meters, meters all cancel, and then one of the seconds cancels. So what we're left with is just 1 seconds. So 8 seconds. That's how long it will take us. So we can finish this off by saying t is equal to 8 seconds. Fantastic. That's acceleration. Hopefully it made a little bit of sense. I'll try to be doing some sort of demos in class, and we'll get a lot of practice work, so that's good. Thanks for watching.